Hello class, welcome to the next segment in week one. And in this segment, we're going to talk a little bit about variables, or more specifically Python variables, but variables that are pretty much universal to all programming languages. But that's going to be the main subject for this video, just sort of a brief look at variables and how exactly those work. So in this example that I have shown up on the screen here, I do in fact have a variable to start with. And I'll go ahead and mention and sort of emphasize that the order here is going to be very, very important. Not just with where the variable is first declared, but also how the variable is declared. So this is enforced very stringently, in fact. So the way that this works is the variable, that is sort of an algebraic symbol that's going to be holding on to some value, whatever that might be. That variable will appear on the left-hand side of this equal sign that's shown on line 1 here. In this case, this variable is going to be called lowercase x. And on the right-hand side is what value is going to be put into x. So, or what value is going to be put on the left-hand side. So this is right here is just something that's pretty simple and straightforward. Here it's just a number. There's not a whole lot of computation involved in that. But usually, or at some point in your program, you're probably going to have some sort of computation, and we'll talk more about how to actually do math in the next segment, do math in Python in the next segment. But the way that the computer is going to read this is it's going to take whatever's on the right-hand side of the equal sign, evaluate what that comes out to be equal to, if it can, and then take that result and store it in whatever's on the left-hand side of the equal sign. Again, in this case, we have a variable called lowercase x, which will be holding onto the evaluation of what's on the right-hand side. And again, here we just have a simple number being 15. That's just a really simple calculation. 15 is just 15. And then that result then gets stored in the left-hand side. And you may also notice here I have a print statement that does not have any quotation marks in it. So in the previous print statements that we looked at, we had print statements that involved quotation marks. And we're going to see what happens when you do a print statement that doesn't have quotation marks. So in the previous examples, some of the stuff that we left off with, here we have print statement with quotation marks, and that told the computer to print something out that literally appears in between the quotation marks. So here we want something specific, some specific text to appear in the console when we go to run the program. When you lose the quotation marks or don't include the quotation marks, then the computer is going to read this a little bit differently. So rather than printing out some specific set of text to the console, by leaving the quotation marks out, we want the computer to look for a variable called this and print out whatever its value is being stored in that variable. So in this case, we have a variable called x, which is holding on to a value of 15. And when we go to run this print statement on line 3, or when the computer goes to run that print statement, the computer is going to interpret this as look up what the value of x is and then print out whatever the value of x is. So again, the order here is very important. You want to make sure that you declare the variable before you try doing any math with it. So for instance, if I were to reverse the order of these statements, so if I try printing out x before it's defined, well, I get that error message, but that wasn't the error message I was looking for. This is the error message that I was looking to demonstrate. It will say x is not defined. And then before you scream at your computer and call it nasty names and ask, why can't you see x is defined down here? And you'll have to remember back to how the computer is going to read things. So whatever is toward the top of the program is going to be run before what appears below it. So whatever is at the very top here will have priority of what appears below it. So here it's going to try to run the print statement before you try putting a value in x. And because you try printing out the value of x before you've given it a value, you will get this error message saying x is not defined. So make sure that when you're going to do any sort of operations with your variable, whether that's mathematical operations or telling the computer to print out what the value of that variable is, before you do anything with the variable itself, you want to make sure that the variable has some sort of value already assigned to it. And also, just to demonstrate how this doesn't work, so again, the computer is going to take what's on the right-hand side and try and store it on the left-hand side. And you have to put the variable on the left-hand side of the equal sign, and only the variable can appear on the left-hand side of the equal sign. You can't put anything else on the left-hand side of the equal sign other than the name of the variable that's going to be holding on to the result of what happens on the right-hand side of the equal sign. So this will not work. It'll get this error message instead if you reverse the order here. So make sure that the variable and only the variable appears on the left-hand side of the equal sign, and then whatever you want the variable to be equal to will be on the right-hand side. And here I'll go ahead and demonstrate how this is supposed to work if everything is working properly. So here again, I have the number 15 being stored in this variable called x, and here I'm saying print out what the value of x is. So what we would expect to happen here is we say print x unquoted. That means look up what the value of x is at this point in the program, and then print out what that value of x is. And we would expect x in this case to be 15. And you can see when we go to run this inside the console, we do in fact have a result that says 15. And there's nothing special about this variable x. In fact, there's a lot of leeway on things that you can use for variables. In fact, you can actually have variables that have multiple different characters in them. So one of the restrictions in algebra classes is all the symbols are just single letters, but you can have multiple letters involved here. But there are a few restrictions, one of which is you can't have spaces. So you would not be able to do something like this. You can't have these empty spaces here. If you want some extra spacing between, say, individual words, then instead of using a regular space, then you would have to fill that in with underscores. So this, believe it or not, is in fact a valid name for a variable. A bit of a laborious task to type out over and over again, but it is perfectly valid. So here I can no longer print the value of x because x is no longer defined. So I will tell it to instead print out the new name of this variable. But you'll see, even though I change the name of the variable, I will get the exact same result appearing in the console here. Another restriction is that the very first letter and the very first character in the variable name must be a letter. So you would not be able to do, say, something like that. That actually is not going to be valid. It's going to say syntax error because it saw a number here instead of a letter when it expected to see a letter. And another thing that you will want to make sure about is your variables should not be containing any symbols that are not alphanumeric. So for instance, I'll say my number, and I'll use the hash symbol, which we learned from the one of the segments at the very beginning that this actually has its own functionality. The computer is going to be ignoring whatever appears after this, so things are not going to be interpreted quite as smoothly. So make sure that when you're using going to declare variables in your programs, make sure that the first character is a letter, make sure there's no white space, and make sure there's no symbols in there. And another thing that's sort of something that will make your life a lot easier going forward is when you're going to create variables or set up variables in your program, it's a good idea to make those variables self-explanatory so that your program is a little bit more intuitive. And this is especially going to be helpful when you start building really large programs that might contain dozens or even hundreds of variables. And if all of them are just single letters, then it's going to be really, really difficult to find out what variable you should be using where. So it's a good idea to make sure that your variables sort of explain what values they're holding on to. So say you have a variable that's holding on to an average temperature. So in that case, it might make sense to call your variable average temperature or something to that effect so that your program is a little bit more intuitive. So that's just an example. I don't know where the average temperature right now in the height of summer is 15, maybe somewhere in the southern hemisphere that's the case, but again, just sort of a best practice. It's a good idea to make your variable name self-explanatory so that it's easier for you to sort through your program, especially if things are not going the way that you expect them to. And another thing that might be helpful is to use variable names that are memorable. So sometimes your first thought on what a variable should be called should be what you call a variable versus maybe going to the second or third thing you thought of and then you go somewhere else in a really long program and you use the first thing that comes to mind instead of the third thing that comes to mind, and you might get a little bit confused there. So make your variable names self-explanatory and use variable names that are something that you will have an easier time remembering as you're building out a program. And another thing that we should point out here is these print statements might seem kind of trivial, but if you don't have a print statement here, then you actually have no way of knowing you might have no way of knowing what's actually being stored in a variable here. So print statements can be very helpful for getting the computer to reveal to you what you otherwise can't see. Not only what values are stored in certain variables, but also tell you where in the program these variables are assuming these values. So we can see here, as of line 3, average temperature is in fact taking on a value of 15. And another thing that's sort of a side note that we could point out is you can actually mix quoted and unquoted statements inside of your print statements, or quoted and unquoted segments inside your print statements. So here I'll go ahead and set this back equal to x, and then I'll say, to sort of a demonstration of that, and I'll say x equals in quotes, and then x unquoted, and that's all part of one print statement. And one thing that's very important is when you go from a quoted segment to an unquoted segment, those two segments must have a comma appearing between them, otherwise things are not going to work at all. So the way that the computer is going to read this off is it's going to literally print out x equals, and then after it's done all that, then it will print out what the value of x actually is, which we can see up here, x is in fact equal to 15. Versus if I do just this, if I do x in quotation marks, then the computer will literally print out a lowercase x, as opposed to printing out what the value of x actually is. So, a bit of a subtle difference, but it is in fact a very important difference. And I could also do something to the effect of, if I wanted to include, say, maybe some units, say x was 15 meters, then again I have quoted segment, comma, unquoted segment. So again, unquoted means look for a variable called this and print out what its value is. And then to go back to quoted, again, I have to have that comma in there. And then here we'll print out meters at the very end of it. So I'll get a result that looks like this, x equals 15 meters. And just for the sake of reference, if you forget a comma here when going from quoted to unquoted or vice versa, you will get this error message. Just a lovely generic invalid syntax error. And if, again, just when you go from quoted to unquoted in the same print statement or vice versa, just make sure you have commas separating those quoted and unquoted segments. And you may also notice that this kind of adds an extra space in here automatically. So that's just something that you'll kind of have to account for when you're going to use print statements. Just keep in mind that when you make this transition from quoted to unquoted, then the computer is going to automatically add a space for you. And one other thing that I'll go ahead and mention while we're on this subject is how to put variables in that involve scientific notation. So if I want to put in, say, the mass of Earth in kilograms, that is quite a large number, although that's probably something that you that you probably suspected. But if you want to include the mass of Earth in kilograms, it'd be really cumbersome to type out 24 zeros, because it's actually times 10 to the 24th. So one way that you can make your life a lot easier is to use scientific notation. And the way you do that is you use this lowercase e. So the computer is going to read this as 6.02. And this e means times 10 to the whatever number appears to the right of the e. So the computer is going to read this as x being set equal to 6.02 times 10 to the 24th. And you can see that the result in the console is also written in the same way. And if I want to do a negative exponent, so the demonstration I'll use this is how many meters are in an angstrom, which is 1 times 10 to the minus 10th. So here I just use a hyphen to represent a negative value for the exponent, and the same would also be true if I want a negative number. I just put a hyphen out in front of it, and the computer will read that as a negative number. And again, I can put this negative sign here. You can see the computer does in fact pick up on that. So that's going to do it for this segment on variables. And in the next segment, we're going to talk about how you can actually perform mathematical operations. So with that, I will see you all in the next segment.